All right, you guys see my screen?
Yes.
Okay, very good. So let's bring this over here. Okay, so I'm going to introduce a few terms today. So we're going to talk a little bit about variables, expressions, and equations. We're going to see what each one of those is, and also the difference between them and why we call them those specific terms. And after this, we're also going to see how to simplify expressions like this. And then we're going to see how to check solutions for equations, not actually solve them. Today, we're only going to see how to check if a number is a solution or not. We're going to solve equations in another class. And after that, we will see how to translate word problems into expressions, maybe equations, and then maybe simplify or solve them. So basically, when we talk, in algebra, we always use letters to refer to numbers that we know or we don't know, or numbers that change in value, okay? That's why it's called variable, because its value varies. For example, x plus 1 is an expression, so its value will depend on the value of x. Okay? For example, if we take x plus 1, this is what we call an expression, because it has a variable and a letter. Could be many variables, many letters. And basically this value, the value of this expression depends on the value of x. This doesn't change. It's always going to be a 1, but this one, depending on what value we give it, depending on the problem, you could take any value, for example. So this evaluates or change in value based on x. For example, if x, let's say if x was, let's say 2, what would the value of this whole thing be if x is 2? It would be
3.
3, that's right. It would be, if we plug or substitute x with 2, will be 2 plus 1, which is 3. What if x was some other value? Say x was 5. X was 5. This will evaluate to what? 5 plus 1, which is 6. Okay, and so on. So it could be basically x is a variable again because it changed in value. It could be anything. Let's say you have a class and this is maybe, I don't know, the age of students. Take the age of student, add 1 to it, multiply by this or that, depending on the problem, really, because this is just a random example, but that's what we mean by a variable. It's just a letter that refers to a value that, that changes in value, or sometimes it could be constant, it depends. But it could be also either one variable, or it could be more, x, y, z, etc. Or it could be just one variable like this. So we call this a constant. So since one doesn't change in value, so we call it a constant. Constant simply means it's fixed in value. Okay, that's what a constant is. Okay, and this one, x, is the variable or the letter. So it's a letter variable. Okay, so that's where the term variable comes from. So variables and letters together, and constants or numbers together, they make what we call an expression. And what is needed for an expression to become an equation? Let's say this is an expression. How does an expression become an equation? What is it missing?
Answer.
Say that again?
Answer.
Answer, or in terms of the
Equal sign.
an equal sign, exactly. So
Right.
equation has an equal sign. Expression does not have an equal sign. If you add a side to it, for example, if you do x plus 1, and you add some equal sign and some statement on the other side, let's say, for example, 3, that becomes an equation. And we already know that 2 plus 1 is 3, so x must be 2 in order for this to be equal to 3. So that's an equation. This is an expression. And then the variable is the letter. Whenever you see a letter in an expression, that's what we call a variable. Okay, and like I said, it could be as simple as this, or it could be something much more complex than that. Now let's see how to, we kind of already did it here. So the value of this changes based on the value of x, the value that we plug in. So that's what we call evaluate an expression. To evaluate an expression means to substitute the variable for a value and then use the order of operations to simplify that arithmetic expression. So for now, this is basically we will also call an algebraic expression. You could say an expression, or to be specific, algebraic expression. Algebraic expression. Okay, so it just means a combination of constants or numbers and variables. That's what an algebraic expression is. So now let's see how to evaluate them. Evaluating. Okay, algebraic expressions. Again, it's not always this simple. It could be, for example, 2x plus 3y minus, let's say, 5. That's also an expression. It has, this is a variable term, another variable term. This is a constant term. It does not have a variable, therefore its value does not change. So to evaluate this, how many values do we need in order to evaluate this expression? We're going to need the value of x and also the value of y. Okay, we're going to need them. These are given. We'll give you the expression, we'll give you the values. You just need to evaluate them. So let's evaluate this when x, for example, is 3 and y is maybe 1. Okay, so again, to evaluate, it simply means to take the values that we know of the variables and we plug them into the expression. Once we plug them, this is an algebraic expression, okay, because it has numbers and letters. But once we substitute the values into this, we get what we call an arithmetic expression. It's just numbers and symbols and operations. And we use the order of operations to simplify them. So plug and simplify. Simplify. That's the first thing you want to do. So basically, we're going to say 2. The operation here between 2 and x is a multiplication. 2x means 2 times x. There's an invisible multiplication, so we're going to say 2 times whatever the value of x is, plus 3 times y. 3y means 3 times y. Then we're going to put the value of y here, minus 5. So I suggest you start like this when you have an evaluation of an expression. Just put some empty parentheses instead of the variables. And then inside those
Professor, so anytime you get a problem like this, it will always be multiplication?
if it's, for example, 2x, yes, it means times x. Unless you see another symbol here, let's say addition or division. But okay, but implicitly, when you see something like this, that's technically a multiplication.
Okay.
So 2 multiply the value of x, which is 3, and then 3 times what? 3 times y. What's y?
1.
Given is 1. See, now that's what we call an arithmetic expression. It doesn't have variables, just numbers and operations. So let's use the order of operations to simplify this. If you remember from last lecture, we talked about PEMDAS. So each one of these stands for an operation. P for parentheses. P for exponents or powers, that's right. Multiplication. And we have division. A for
Addition.
addition, that's right. And finally, we have subtraction. Always do it in this order. Don't forget multiplication and division, you do left to right, whichever appears first. Same thing with addition and subtraction, you evaluate them left to right. So these are left to right, and these also, when you see them next to each other, you do left to right. All right, so for this one, we don't have anything inside the parentheses to simplify, so we move on to the next one, exponent. We don't have any exponents here. Then we move on to multiplication. Do we have multiplication here?
Yes.
How many?
2.
Two of them. We have one here and the other one here. So we're going to evaluate both at the same time because it's the same operation. We're going to evaluate the multiplication. So 2 times 3 is 6. Positive 3 times positive 1, that's positive 3. Okay, that's a 6. Bring down the constant. It doesn't have a variable, so it doesn't change. Then, now what do we do first? Again, this is addition, right? This is addition.
Right.
Next to subtraction, so always evaluate these two left to right, left to right. So this one appears first. We're going to do that first. So that's 9 minus 5. That's 14. Okay, and we just evaluated this expression with these.
4.
That's right. I'm sorry, with these values. Okay, just
Oh
evaluate.
yeah, because I was wondering. I said 14. I said, how is that?
I'm sorry. Could you get closer to the microphone? It's hard to hear you.
I said I was wondering how you got 14.
Oh yeah.
I said, that, yeah.
Yeah, I was thinking about addition for some reason. I don't know why. Okay, so whenever you see a question that says evaluate this all that it means, just plug and simplify. Plug and simplify. So expression could be as simple as this, could be like this, or maybe even something more complex than that. If you take a look at this example, please mute your mic. Just muted your mic. You have some background noise there. So let's take another example. Let's say 3x to the second minus, let's say 4x plus 1. Okay, that's another expression here. This one has the same variable, but to two different powers. This one is x to the second. This one is x, just x, or an invisible power 1. So evaluate when x is, for example, some number, maybe say, probably, I don't know, some number, maybe 2. So we have only one variable. We want to evaluate this. So again, I'm going to take the 2, and we're going to plug it into the expression and simplify. So 3, and again, just leave some empty parentheses for the x. Keep everything else the same. Only thing that will change is the value of x. So again, write this expression like this. Without the x, the power is invisible 1, so we don't need to write it, plus 1. Only remove the variable, and instead of the variable, we're going to plug the value. So x is 2, so we're going to put 2 here, and also here. Now we're going to use the order of operations to simplify. Again, PEMDAS. So what do you think we evaluate first in this expression?
The exponent.
The exponent, that's right? So we don't have the anything inside the parentheses. So when you say parentheses, nothing inside to simplify. So before you do this, that's a multiplication. So we're not doing 3 times 2 yet. Multiplication is here, but the exponents must be done first. So we evaluate this, the exponent, before the multiplication. So that's a 4, that's 3, and let's keep everything else the same for now. I'm gonna get back to those later. Only try to do one operation at a time. If you try to do more than one operation at a time, things get confusing. Make sure you write the whole line. Every time you go from one step to the other, just write the whole expression. It makes it easy to follow and less confusing. So we're done with the exponent. What's next? The multiplication. Again, as you can see, we have two multiplications here. So we're going to evaluate both at the same time. So that's a 12, take away 8, plus 1. And again, we have these two together. Which one we do first?
12 minus 8.
12 minus 8, that's right, left to right. Whenever you see an addition and subtraction next to each other, do the left one first, then the right. So this is going to be done first, so that's subtraction. So
It's going to be 4.
That's right. Final step is to add. So we get 5. Okay, so be careful, especially if you have powers, if you have multiple variables and signs. So just plug correctly. If you don't plug the value correctly, you won't get the right answer. So be careful as you plug. Again, always leave some empty parentheses. Just put empty sets of parentheses, plug the values into them. Okay, let's do one more. Sometimes expressions can come in fractions like this. I don't know, 3x minus 1. Okay, and maybe plus 3. And over, you may have some expression here. Let's say 4. 2 to the third, probably minus 5. As you can see here, we have another expression, okay? An expression, it doesn't have an equal sign, only has variables and letters. So that's an algebraic expression. It just happens to be in the form of a fraction, but we can evaluate this the same way we evaluate the other one. So here we only need one variable. Let's say we're gonna need some x somewhere here. Let me actually change this. I need a variable there, so let's make it an x here. The same way, so we're gonna try to evaluate this for some value, maybe when x is, let's say, is 1. Okay, so all I have to do again, take that variable, plug it into the expression, only substitute the x, not the other ones. Only the x will be substituted by its value. So we will be given this, you will be given the value. All I have to do is plug and simplify. So this will be 2. So we have 3. Another way of expression of multiplication is with a dot in between. It's not a decimal point, just a dot. For example, 3x, you can say 3.x or 3 dot x. Well, in this case, so we plug in x. X is 1, so we're going to put 3 times 1 minus 1 here, plus 3. Okay, so plus 3. Okay, so the reason I didn't want to use parentheses again, I could have used parentheses here, but we already have these parentheses outside, so we don't want to make things too confusing. So you can express multiplication with a dot. It's not a decimal point, unless, of course, we're talking about decimals, then it will be obvious that we mean it as a decimal point. What is x again?
X is 1.
It's x is 1, right? So instead of this here, I'm going to put 1 minus 5. Once you substitute and you do that, correctly, then you start simplifying. So order of operations here. So again, PEMDAS, work inside the parentheses if possible. Yes, we can work here. So we have 3 times 1 minus 1. So the multiplication comes before subtraction. Multiplication comes before subtraction. So we're going to do 3 times 1 minus 1, which is 2. Okay, this 2 is here. 3 minus 1 is 2 plus 3. Over, go to the bottom and start a new order of operations for the denominator itself. Nothing to do inside the parentheses. We move on to exponents. We have an exponent here. We're going to evaluate this, not 4 times 1 yet, but 1 to the third, which is 1 times 1 times 1, That's 1. So this is 1, not 3. A lot of people make this mistake. It's not 1 times 3. It's not 1 plus 1 plus 1. It's 1 times 1 times 1, which is 1. So it'll be 4 times 1 minus 5. Back to the top here. So we have multiplication and addition left. So obviously, we do the multiplication first. 4 plus 3. Back to the denominator. Again, we have multiplication and subtraction. Multiplication comes before the subtraction, so that's 4. Take away 1, or take away 5. So that's 7 over 4 minus 4 minus 1 minus 5, which is negative 1. We're going to talk about the signs later in detail. So 4 take away 5 is negative 1 because we take the sign of the higher number and we do the difference. So this we can write as just negative 7. Okay, when you have a denominator of 1 or negative 1, you can move the minus up, becomes just 7. We'll discuss this next class. All these signs, we're going to talk about them in detail. Okay, so that's basically what an expression is, just numbers and letters. We call it an algebraic expression. So to evaluate it, we simply plug the values and simplify them. So now let's talk about equations. Identify solution. Okay, well, before we do that, let's see how to turn word problems into expressions. So translations, we're going to translate words or sentences into expressions and simplify them. So translations. Translation of word problems. So sometimes you see twice. This isn't a problem here. So twice a number. Okay, so twice a number increased by, let's say, 5. Okay, so believe it or not, that's a sentence, but also that's technically an algebraic expression. We can turn it into something like this with just numbers and letters. So first you want to do when you have a word problem like this, you want to understand it first. Read it a couple of times, understand it very well before you translate it. If you don't get the right translation, you won't get the right answer. So now, so twice a number increased by 5. So make sure you understand each word in the sentence, know its translation or its symbol, and then you start writing as an expression. So twice a number. So we don't know a number.
So it would be,
yes?
would it be like 2 times x?
2 times x. So whenever you see a number and it doesn't have a name or something, feel free to give it any letter you want. Could be x, could be a, could be b, anything. It doesn't matter. So twice a number we don't know. Let's label it x. Increased by, so we all know increased means?
Add.
To add. That's right. The operation is to add. And 5, of course, all these are self-explanatory. So now, I'm just going to translate this. So twice a number means, for example, twice x means 2.
Would you put the x in parentheses or no?
Oh, it wouldn't matter. You could do this. If it's just x by itself, it doesn't matter. But if it's twice the sum or something, then you use parentheses. But for now, 2x is fine. Increased and 5. Okay, so that's basically how it's can be pretty simple to translate algebraic expressions. So all the additions added, increased, or for subtraction we say decreased. Let's do another one. So let's say the quotient of, let's say, twice or 3 times the number. Three times a number. And let's say 7 decreased by 6. Okay, that's another sentence again. We're going to translate this into a word problem. So the quotient of 3 times a number and 7 decreased by 6. So translate this into an algebraic expression. First, again, understand all the keywords and now the translation of each one. So what do we mean by quotient?
Division.
That's right. So the quotient is the result of division of 3 times a number. So how would you write 3 times a number if that number was x? We can say
3x.
Yeah.
that's right. This whole thing becomes just 3x if we label the number as x. And 7 decreased, of course, means
Subtraction.
subtraction, decreased by 6. Okay, so let's put this together in one expression. This will be, so the quotient, whenever you see quotient, that means it's the division between two things. So you gotta write the division and then you gotta have something here and something here, the divisor, the dividend and the divisor. Okay, so what goes, what are we dividing? What goes on the left side of this?
3x.
That's right, so the quotient of 3x and something else. What is that other thing? And
7.
and 7, that's right, and decreased by 6. That's it, that's the expression here. We translated it into an algebraic expression, only numbers and letters. All the other terms, minus this or subtract or decrease, all mean subtraction. Of course, addition, added to, increased by, all those terms. If you see those in the homework problems, basically use the appropriate symbol or operation. What else? Let's do one more. So 5. So 5 times the sum, or the difference, or rather, sum is for addition, difference is for?
Subtraction.
That's right. So 5 times the difference of a number and let's say 5. Okay, so 5 times the difference. Again, keyword is a difference. Times, of course, 5 times means 5. But before we say that, so 5 times what? So when you say times, we have 5. I mean 5 times something. 5 times what? How would you write the expression? Well, obviously we have a 5 here, but that 5 is multiplied by what?
By x. No, the difference of a number.
So the difference, it has to be, so it's not 5 times something. It's not like 5, as we saw, 3 times a number. It's not 5 times a number, so it's not 5x. It's 5 times, for times we're gonna use nothing here but parentheses, times a difference. When you see 5 times a difference or a sum or a product, so you need parentheses. So 5 times, not a number, but the sum, or the difference in this case. Difference of what? We have to have two things here.
A letter, which we can use x,
That's right.
and then 5.
And and 5. You can even add something else here. Let's say added to for example, 9. Okay, so you can say here 9 as an example. Okay, so that's basically how you do your translations. Just make sure you use the right symbols or right words. Once you translate it, turns into something like this. Then from here you can either evaluate it or do whatever you need to do, depending on the problem. All right, so translate. We did the translation. Now the last part we're going to do is how to check whether a solution checking solutions for equation. We're not actually gonna, we're not going to solve, we're just gonna check for solutions. So will be the last part to cover today, solutions of equations. Okay, so let's say x plus 3 is 7. So check, we're gonna check a couple of numbers. Let's say check 2 and also check 4. Means we're gonna see which one, if these are solutions or not. So let's start with x2 here and x4. So with x2, is 2 a solution to the equation?
No.
Solution here? No. So the only way to find out is to take 2, plug it into the equation. Now it's an equation, not just an expression. Plug it into the equation and see if we get 2 equal statements, one on each side. So we're going to plug the 2 into the equation. So it will be 2 plus 3. Then we say, is it equal to 7?
No.
That's right. We add that little question mark because we don't know. Yeah. Then you simplify each side and see if you get equality or not. So this is 5. And this is 7. So it's not equal to, but rather the opposite. Should we say not equal to? 5 not equal to 7. So x not a solution. x2 is not a solution. Okay, and same thing for the other one. So you go to x4. Same thing, we don't know yet if it's a solution, so we're going to take it, we're going to plug it into the equation and see if we get 2 equal sides. If we do, then it's a solution. So x is 4, 4 plus 3, so we write it like this. Then we say, is it equal to 7? We need that question mark because we're not sure yet. Then we simplify. 7 is in fact equal to 7. As you can see, we say this checks. This number checks. So therefore, 4 is in fact a solution. Okay, so that's basically how we check solution for the equation. Could also be something like this: x plus 1 minus 3 equals, let's say, 5. Let's check, let's say, for example, 1. Check 1. Is there a solution? We don't know yet, so we're going to plug it and see if it works. By the way, right after this, we will head over to the discussion board and continue this, okay? I'll show you the lesson plan, show you the homework, and also upload this lecture to the lesson plan. You'll find it there, okay?
Okay.
If you have any questions, you can post them to the discussion board. So we're gonna plug 1 into this and see if it checks. So 2 times x, x being 1, plus 1 minus 3. And again, we say, is it equal to 5? Use the order of operations. What do you do first here? Of course,
You do within the parentheses.
That's right. Minus 3. And we still need the question mark. We're not sure yet. This is 4 minus 3. Is it equal to 5? Obviously not. This is 1. It's not equal to 5. Is 1 a solution to the equation?
No.
No. That's it. So that's basically how you check for equations. So we're not solving them, we're just checking for solutions. Another class, we're going to learn in detail how to solve equations. So x1 not a solution. Okay, so let's continue this on the discussion board. If you have any questions, please post them there. And I'll post the homework right after this, right when we go to the discussion board.